So today we are going to discuss about date and time module, random module, calendar module. Okay, so let us start up with the random module first. So talking about the random module, you can say it is an inbuilt module in Python. Okay, and it is used to generate some random numbers. Okay, so these are pseudo random numbers, means these are not truly random. This module can be used to perform any random actions such as like number generations, printing a random value of for a list of strings, tuples, any elements, finding out from a sequence. Okay, so that is what a random actually is made for. Okay, so we will be just doing some sort of functions for this random module. Okay, so there are functions like randint, okay, random range or rand range. Okay, a lot of functions are there inside random. First of all, we need to just import it as import random, and we'll get to see the directory of this random to just tell you. So we can see we have all these like from choices, expo variate, gamma variate, gauss, okay, seed, sample, randint, random, rand range, shuffling, okay, uniform distributions, and a lot of things are there. Okay, if we just talk about this random state. So what we are going to do is we are going to just put in one by one some of the functions which are highly used. Okay, and we'll get to see how it works actually. Okay, so this random function, when we talk about random, this is going to generate random numbers simply, right? Okay, and always we say it's not actually random, rather than it can generate pseudo random numbers. Okay, fine. So there are some functions like seed. Okay, so when we say pseudo random numbers, that implies that these random generate numbers or randomly generated numbers can be determined using the random function. No? So random function generates numbers for some values, maybe 0 to 1, 1 to any kind of range you want, or like we can say between your ranges or something. So for some range or some values, that value is called seed value. Okay, that is called seed value. Whatever the value is being generated, that is called random as well, and you can say the seed value. Okay, so seed function I'll be discussing first. So seed function is used to save the state of random function. Okay, so that it can generate same random numbers on multiple executions of the code, or on the same machine or on different machines, for a specific seed value. Well, I'll show you what and how it works. Okay, so going with the seed function in the beginning. Okay, so I'll just bring random dot, you're gonna write seed. So what it does, initialize internal state from hashable object. We're not going to go over all these things. Okay, so what I say that it will be just you know you can say giving you a state. Okay, a state where the values, okay, which will be generated by this random function, it will be in same execution level. Okay, execution level, when we say, you can say at a same random state or a random area, like in between ranges, it is going to give some same sort of value for every executions you can take. Okay, so let me just write a code. Suppose what you're doing, initializing a function, we're gonna do it random.seed. So let me just make it for I in range of 10, right? What we are going to do is we are going to write random dot seed. Now you put any number inside, that doesn't matter. Okay, whatever you want to put, any number can be used in place of the parameter of seeding. Okay, so we'll just put that, and we'll just print some values. Okay, so I'll just put 0 and I'm going to print, I'll just name it as y equals. Alright, so just to make it, or let it be random dot random 1 to 5. So if you see, I am taking a random number. Random, you know how it works. For random, if you just go with the random function, so when I write random dot random of 1 to 5, it means I'm going to get numbers from 1, 2, 3 and 4, right, and 5 as well, because it is not a range. We are just giving some intervals. Intervals also in the sense like you can get 1 and you can get 5 as well. Okay, so you have a possibility of giving getting every number. So here you can say it's just random sampling, where every element has a possibility to come, or has a probability to be printed, right? Similarly, you have something called as rand range, where you don't have this possibility. If I write random dot rand range of 1 to 5, you have possibility of 1, 2, 3 and 4 only, right? You're not going to get any number apart from your 1, 2, 3, 4. Here in this case you may get 5 as well. Let me just, so you can see it's coming, right? So what we are going to do is, here instead of this I'll just make it 3. So for I in range of 3, random dot seed of 0, what it's going to do is a same value is going to print and in the same random state. So you can put any value inside of 0. You can just put 2, you can just put 5, you can just put 5, you can just put 3, and you can just put 1, 9 and anything. See, seed is something which will just give a same execution pattern, which it is not going to change random every time. Then okay, it will just fix that this is the state you have to take every time. Okay, so this is rand range, rand end. So proceeding next, we are gonna get it into random. So when we talk about direct this, it just gives a random variable, a number, you can say, in that term. So random number in the intervals of 0 to 1. That is thing which the random is going to opt for. Okay, and in this case, the seeding values, you can get any value between 0 and 1. It is what it is going to follow. Okay, fine. And one more thing, like this particular function can also be called as for generating random floats, because for random integer we have rand int, right? For floats you don't have any such function. So this is also called for generating random floats, as it generates number between 0.0 to 1. Okay, so let me just write a code for it, and let me just run it. So you can just see it's coming over now. I can just multiply it by some values to get it. Any random values will be given, but only specifically in the 0 to 1. Okay, now coming to some other parts, right? Like we have choice and shuffling. Like in some parts, when we are going to get to understand about the questions, shuffling and choosing to return a random element from a sequence, from a string, tuple, list. Okay, in that case, you cannot just specify a range of elements, and you want to get a sample out of it. Understanding about sample and population. So taking out a sample from a population, like taking out one particular element from a data set or something kind of thing that, like, okay. So let's just take a choice and see how it works. Suppose I have x value which says we again take a range of numbers between 10 to 30 in intervals of 2, intervals of, yeah, let it be no intervals. So we are going to take a tuple of all these values, and your x be like this, okay. So what we want is some samples. Choosing is and sampling both, like, behaves in a similar way, but I'll show you what exactly it is first. So we write random dot choice, a random element from a non-empty sequence. It just chooses a random element from a non-empty sequence. So we say I just want x, so you can see random you're getting x, any random element, but that is coming from the sequence given. Okay, so sequence is my x and I'm getting one random. So suppose I just make this thing again in a loop kind. So for I in range of 3, I just want to print random dot choice of the x. So you can see any random value is coming in, right? I believe this can be done in case of string as well. Okay. So here is something which gets a change. That is like random dot choices. Now when we come to choices, it returns a k size list of population elements chosen with replacements. Okay, this has got something different. You have probabilities, you have cumulative weights, you have weights, you have population from where you need to draw. So we'll talk about it. Okay, but before this we will be going into sampling, understanding about samples. So sampling is another important feature. Like here, just try to draw one random element or number of random elements from a population. So in choice, you don't have, like, you just want one element, you get one, and in sample, if I say from this is my population x is my population, and I want to draw I want to bring out some 4 elements from my x, and I have at least 10 20 elements, so I want 4 elements from my x, and I get 29, 11, 22 and 15. So this is what a sample is going to do. It can bring any k number, or you can say k samples from population. Alright, so this is what sampling is going to do, and choice has got, that's what I say, that they both are giving the same thing. They are just picking out like one element, and just giving out some samples from, exactly, you can say that sample is one keyword, you can say, which is coming out from the population. But a slight difference is that this is going to give you 1, this is going to give you, as number you want, and that's it, like, okay. So okay, this is, we can write it simply, returns sample from one sample. I should write one sample from population. Okay, and This is giving you k samples from your population. So this is, I believe, it's very understandable. Okay. Okay. When we come to choices function, no, choices was there. So that is going to return multiple random elements from list, even with the replacement methods. There are samplings with replacement, there are samplings with not replacement, no replacements. Right. So in a cases, suppose, for example, let me write it choices k samples from population with replacements. Adjust thing changed. So now what it means, suppose I write that I have my x, no, and I'm going to write random dot choices. So I have got population first, so my population is x. Now weights, I'm going to define weights. Like for my x value, every different value what I'm having in. So I'm going to take first 3-4 values of x, okay, whatever it is, and I'm going to give them some population in terms of like how much percent or how much weight has to be given for that value. We can say it's like an optional parameter for which is used to weigh the possibility of each value, and then the accumulated weights parameter is there, which you can also give, and there are some option. These all are optional, like sequence, what you say, population is mandatory. Otherwise every other pattern or every other parameter is optional. So you can just define what is the length or something you want of your. So let me say it's like 2 4 1 3, something like this, and I say k equals 2. Let me see. So I just want 2 elements. Okay, let me first make you see that what is this x. So I have 10 11 12 and 13, out of which I have said that weights of my elements. So the highest weightage I have given is 11. Less than that I have given to 13, okay, then to 10, and then to 12. So I exactly want 2 elements. So I'm getting 11 13 11, but 11 was coming right now. So I need to change it. I need to change it to 29 something. You can see as many as you want. With replacements you are getting a random number there. Okay, so I don't want to make it very large, so make it like 9. So if you see that I'm getting k samples, okay, from my population with replacements, if you see, so I have 10 for 1 2 3 4 times, okay, I have 11 for 1 2 times, okay, and I have got 13 for 1 time, all right, and I have got 12 for 1 time, and these values may change even for every outputs. This is something called choices. Okay, when you have all these coming up in numpy and things, when you'll be going in vectorizations. So the last part is your shuffling. Now shuffling is another important thing for a random, because like suppose you have a list, you have a tuple, or you have any kind of sequence where you are going to change the position of elements. If it is required to change the position of the elements, shuffling is the operation what you are going to perform there. Okay, and it means you have to give the function what you are going to put it there. Okay, so let me just write down, and you can see this. We have x, no? So I'll just print my x first so that you can see. So this is x, okay, and okay, so this is my x, and I'm gonna do a shuffle random dot shuffle the x, and then I'll be again printing the x. So I'm going to print only the first 5 parts of x now, like first 5 elements only. Okay, let me print it all. What it says, tuple. Oh, we made one mistake here. Anyways, so let me just get it done. That's what a thing, when we take tuples, we have learned in daily life. When we take tuples, you will know a lot of operations then will not be done on that, right? That's what immutable and mutability is. Okay, anyways, so you can see shuffling again. I'm gonna do one more shuffling to it, so you can see the shuffled elements coming back again. So that's what shuffling is, and that is what random state seeds and all the randomness all about. Okay, so this is like the major module, what it says about the sampling, the random, randant, all these are some highly used. Okay, right? So yeah, moving to the next module now, which is your math module, right? We'll be moving to the math module. It's quite relative to it. So math module has got a very similar things. It's not very much weird now. Simple maths, what you have learned in classes of 11th, 12th and all. Okay, that's very simple. Nothing changed, like sine, cos, tan, logarithmic values, okay, addition, subtractions, okay, then Euclidean distance, error functions, and a lot of things like that, infinity and Euler's number, some constant values I'm talking about. So in maths there are some constant numbers. What I'll just print first of all, okay, what all these are. So first of all, I'm just going to write for all the constants. Okay, so it's you have to import maths. So it's just a module, which will help you to figure out with all the mathematical calculations and basic ones. Okay, not very high levels. So for high levels, you have different packages as well. But yeah, for a basic level and some part of when you say about high levels, it's all about the dimensions. So if it is not in a dimension pattern, it's very simple obviously to calculate with this. So we have got math.pi, we have got math.tau, we have got math.infinity. If I run this, you get it like this, and majorly like you use nan as well, which is called not a number, a floating point, and Euler's number. That's all we have. Yeah, so these all things are there. I guess this everyone knows about it, so anyways, this is what we have in a tuple. Okay, so what I'm gonna do is I'm going to put it as a list value, copy, and values in a list format. Then it's nano. Then I'll write the constants are named as phi, tau, Euler's number, then you have nan, oh, infinity is there, infinity and infinite you say, and then you have nan. So I'll just change a bit. It's fine. Euler's infinite has to be changed. So nan is in the last. After tau we have infinite. Let's say I have here. Okay, so what we're gonna do is to zip the values. Okay, these all are things what we have done in previous classes, just making it done in a pattern way. So we are going to zip the constants and their values in a zip format, and we are going to print that dictionary. And let me just look into the values. Yeah, so you can see the constant values for 1 1 and all. Okay, and it's very simple. Okay, so getting ahead of this now, coming to the functions which are important, okay, so let me come to one by one, like before going, I'll just again, as for all, we will be first printing the directory of the maths to know what all functions you have. So you have all these from acos, assign, a tan, ceil, combinatrix, permutations, right, sine, square root, tan. Okay, a lot of things are there. Anyways, so we'll be starting with some basic ones, like finding values for sine, tan, cos, right. I think this is very simple. So we will be having some degrees. So suppose if I say I have 90 degree of value, okay, and in radians, how much it is? 90 degrees to radians. Yeah, anyone who can tell? 90 degrees in radians, how many, like what's the value? You can calculate. Anyways, so you can just go and do it in Google as well. You'll get 1 point something, 57, approx like that. So I'll just write radians equals 1.79 or 57. Okay, so here we go. So for sine, we have math dot sine function. For this we have math dot cos, and for this we have math dot tan. These simple three functions are there which can do it. But yeah, apart from this, we have some conversions, which is not stated, like suppose the value you're getting is in degree, and you want to do it in radians. So suppose if you have an angle, okay, and you want to convert it from radians to degrees, you have a function called math dot degrees. Now in a similar way, you have a degree, okay, and you want to get it convert into some radians. I'll make it done, otherwise it might confuse you. So suppose that I want to convert 180 degree into radians, okay. So I'll just be writing maths dot radians and 180. So converting degrees, well, I'll just write it down what it does. So radians convert degree to radians. I'll just write a short form, you can understand from there, right? Okay. Degrees are gonna convert radians to degree. That's that simple thing it's gonna follow. Okay, so we can do this one also, maths. Anyways, write 90, we'll check what it gets. Yeah, 1.570 something you're going to get in this. Okay, and the same maths dot degrees, put this value and I get this. No, so if I say that I want to find a sine value, so if I say sine value of this, yeah, what is it? Okay, you have to put it like math dot sine. So math dot sine value of this is going to give you 1, which is, you know, sine 90 value. Okay, and similar to this, if you take maths dot cos 90, okay, it's th, sorry, so get this value, and if we just convert this to like this, minus of something, you know, and in most of the cases, you know, when you take for a cos, you get negative values, you know, you can see the pattern of the cos. You might, if you remind, like try to remind the graph of cos and sine, you can understand how it works. Okay, suppose for a quick thing, I'll just show you some graphings as well. So just a quick graph. So suppose I'm going to take some random numbers, random dot random of, okay, I'll have to store it somewhere else. So just some values and sign of all these, so I have to put it as okay, so num with maths dot sign values of num. Let me just make a plot of it. Yes, VLT to show figure non-integer step for rand range. Yeah, might be okay. So a graph which would be coming in. Let's check it. So sine has, okay, that's very cool. where we're getting. So we would be getting a graph. That's not a good one, anyways. It's a whole lot mess. So it's not very good values, but yeah, you can see you're getting some thing at least. Okay, instead of this, if I try to draw values between randoms. So this has got at least a good thing to see it. Okay, so this is your sine graph, values between -5 to 5. Just I'm taking a simple thing. Okay, and you can see how the graph changes. So not to talk much on the sine, cos and tan. Moving next. Okay, degrees and radians also we have seen. It's quite simple thing. Then you can just take log values, okay, which is going to return some logarithmic numbers. Okay, so we can just try it out to base 10 or to base 2, whatever you want. Okay, so just writing maths.log, a lot of things are there. It returns logarithmic of x to the given base, maths.e base is that what it is calculating. So you want log of 10, get it 2 point something, because your base is, what is your base here. If you might have seen again, your base is maths.e. Here base is equals to maths.e. If you want to change it to maths.log of 10, and I write it 10, so like we are gonna get it 1. Now suppose I write maths.log of 1p, returns the natural logarithmic of 1 plus x with base e, right? Log of 1 plus x with base equals to maths.e. So log of 9, again you get the same value. See, if I'm writing 9 means 9 plus 1, 1 plus 9, that is log of 10 with a base e, again getting the same value there. Okay, so that's what a log actually takes. So if I just show you some log values, np dot log of, I have some. What is np? Np is my array, okay, numpy array. We will be talking about it later onwards, but for now let's just see that this is my num. Okay, this is my num values. Okay, for example, which is a list here as a kind of. Now I'm taking first 20 numbers. So these are my first 20 numbers of, okay, and I want to take a log. I want to see how this log values looks like. So I'll take the first 20 numbers and I'm going to see maths dot log values of these first 20 numbers, and I believe that it is an array, so it is not going to take it. Yeah, so we'll take np.log. Anyways, what's it saying? PLT. Okay. Yeah, so for the first 20 it is going to be nan and nan, so that was the thing, that graph is not coming in there. Okay, for the rest of the things, these are the log values. Okay, so you can just simply see that for I in range of 10 to 100 with intervals of 2, print their maths dot log values, not 200 till 40 with intervals of 5, print log values of I. So I'll just print I and then their log values. So log value of 10 is this, as you can see, with a base e by default, and all these are coming with base e. Okay, all values are with base e there. Okay, well, I think this is also fine. Now coming to the next part, in mathematics there are some concepts of like permutations, combinations, a lot of things. So suppose we are going to use the function of permutation here. Okay, so if you just want to find the number of ways to choose k things from some number of elements. Okay, so let me just write it. Okay, and suppose if I say that I want to find the number of ways to choose k things from n items. Okay, you need to understand about this. You are going to choose some k things from n items. Okay, this you need to understand. So you have to initialize k and n first of all. So I'll just write k and n, and permutations and combination, I guess everyone knows about it, right? So suppose that I'm going to initialize the number of items to choose from. N is kind of 7 and k is 5. Okay, so what I'm going to do here is maths dot now number of ways to choose. This function defines to bring out the number of ways to choose k items from n items without repetition and with order. So I need to write n and k, and I'll write it like n comma k. So you get 2520. Okay, so this function actually returns the similar thing what you see, number of ways to find out something. Okay, so n is a positive integer, okay, which is very required. Okay, which says that it is the positive integers of items to choose from, so from where you are going to choose it. Okay, then k is your positive integers of items to choose, so from where what to choose. Okay, I believe this is fine. So similar, like you have power function, power is something similar to arithmetic operator you have seen. So it's like maths dot power of 10 to the power 5, you get it like this. 10 to the power 2, you get it like this. So it returns it in a float kind of thing. Okay, and there are functions like product. Okay, so suppose I have a sequence of I have a sequence, I kind of 2, 4, and 6, and I want a product of it. So I can just write maths dot product of this sequence, and it's 6 into 4, it's 24 multiplied 2, 48. So if you can get a factorial, you want to take factorial. So for factorial you have a function, but if you just want to try like 5 factorial, it's 120, and like how it goes. So for I in range of, if it says to give a factorial, like 5, so you need to take it from 5 plus 1, and then you are going to print it in backward order, like you are going to just print the values of I. So instead of all these, it has to be started from 1. So how you can calculate it again in a different manner is, you can just write it like this pattern, that you can just put it in a list. So I for all these, and you get this, and you can just apply maths dot prod of this, and I can get the same thing. So I can define my own function here of a factorial mentioning the x value, and I can return the user the values of x to 1, and suppose if the value is 5, I can get 120. If the value is gonna be 100, I can get that value. If the value is 0, what in that case? The factorial is 1. Okay, so we are just simply making another function, okay, with the help of inbuilt function. Again, we have been doing all these things previously as well. Okay, so these are some inbuilt functions which are very helpful, when you do some use cases, finding out some good things. So these are something which helps you a lot. Now we have been working with function, like if you remember, spelling error. Suppose we have been doing it 100 divide by 3, get at 1. So we have something where we can help it out using this with 100 comma 3 oops, and you get a value of what it does. The same thing, getting remainders, these are another thing. Now we can just check it like the distance. If you want to know, you want to find the distance between 2 points like P and Q. You remember the formula, Euclidean distance formula, under root of x2 minus x1 plus y2 minus y1. Okay, so that's like you can calculate it. So you can do it using some between one dimensional, two dimensional, and I'll show you. See, so if you can recall me, so suppose I have x and y. Simply I'll tell 5 and 4, and I want to calculate the distance. I'll say maths dot distance between my p and q values, and it says p is not defined, q is not defined, obviously, so I'll just tell it is p and q. So what's the problem? It is not iterable. Okay, so being one dimensional, it is saying it's not iterable. So what we have to do is to put it at least inside the list pattern. Okay, and so we get the distance. So this is called a one dimensional distance. Now suppose now you have x1 as 5, you have x2 as 3, you have y1 as 4, and you have y2 as 5 or 1. Okay, suppose 3. Now x1, x2, y1, y2. It's very simple. Suppose if I'm plotting a graph with x1 over the y1, okay, and I say it has to be red colors, plt dot plot x2 over y2, some orange colors, no, okay, a little bit blue and orange. So you are going to get some sort of values at least. Let me just check it. No, 5 and 3. Okay. x1, y1, x2, y2. So what's the thing? What's the problem? P is has it not been initialized? Yeah. So we are getting one line. Okay. One point. One. Okay. What if we write P versus Q? So yeah, 2 points. Anyways, fine. So we have P and Q as two different values if you see. And if you want to find the Euclidean distance between these 2 points, you have just to write dist and that's it, P and Q, and it will be giving you this. Okay, so coming to the next module, calendar. Okay, now for calendar it is quite simple. A lot of things are simple. Suppose you want to print a month calendar. Okay, you just have to write calendar dot the month, and then inside you just have to write the year, the month. Okay, width and length if you want you can just write it. So it returns a month calendar in a string pattern. Okay, so the year and the month you have to write. So you say that the year is 2022, the month it is 10, and it is going to print it in this way, so this is a string, though. You can see slash n and all backslash n. So we are going to use print to avoid this output. So and this way you can see this thing coming out. Okay. Okay. So now with the calendar, you can see you can print a year, you can print a day, you can just look on to some weekdays. Okay, and let me show you. So suppose we want to look into year calendar. Okay, so year calendar you can just simply look in like I just want to see the calendar of year 2023. So you have to write calendar dot year and the year will be equals to 2023, and that's it. You get to see what rest. You have some other things as well, like W should be 3, L should be 5, suppose. So you can see it's all about length and width. So you can see it has been increased. So I say length equals 2. That's not very far coming in, spacing and all. Okay, so I'm not writing about all these. Yeah. Kind of fine passing error. Okay, now coming back, suppose the point is now that you want to see like the weekdays. Okay, so we have a function called iter weekdays. Okay, now iter weekdays is going to return an iterator for the weekday numbers. Okay, that will be used for 1 week, like Monday to Friday. Okay, so the first number from the iterator will be same as the number returned by the first weekday. Okay, so I'll just show you how it works. So we would be writing it calendar dot calendar. We'll say we're gonna say iter week, yeah, first weekday. So first weekday is 0, suppose, and this we have suppose stored in some our week pattern. WP is our week pattern. Okay, and we are saying for I in range of some numbers. Okay, or for like I in your this week pattern. Okay, you're going to print the values of I. Instead of range, we are going to use WP dot iter weekdays. Okay, print values of I. Or you can just take, I'm going to use list comprehension simply, so in one single line work will be done. So you can see week starts for 0, 1, 2, 3, 4, 5, 6. The same thing. I'm just okay. Whatever we say, week starts from 1. So 1, 2, 3, 4, 5, 6. Then comes 0. So that means according to the days, like Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday for 0. You say it starts from 3. So 3, 4, 5, 6, 0, 1, 2. It depends. Whatever you say, like whatever you define there. Okay, next is instead of iter weekdays, we can take month days. Okay, method is not callable. We have to put the function, and year and month has to be defined when we are talking about iter month days. Okay, what happens in iter month days? It just specifies. You have to just specify a year and a month, and then the month days is being given. So I'll just write for this particular year and this particular month. So the year is 2023 and month is gonna be 10. So you can see the list of values. So it's 0, 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on it goes for the days actually. Okay, based on things. So okay, fine. So this is like calendar module importance. These things are there. All right. Okay. Now, if you want to check a year is a leap year or it's not a leap year, you can just check it by using the leap function. So it's all about calendar dot. So you're going to get a boolean value. Is this a leap year? Oh. Okay, in fine. So we have used some wrong function actually. It's not leap days, it is a leap year. Yeah. Okay, now calculating the number of leap days. Suppose if a year is having a leap year 23, 24, yeah, 24 is a leap year. Okay, so what you need to do is 1 and 2. So returns the leap number of leap years in range of 1 to 2. So in between 2020 to 2024, how many leap years we have? 1, right? That's very simple. In between 1870 to 2024, there are total this much number of leap years. Okay, that's I guess it's simple to understand. Okay. So suppose I write it for WP. No, if I write, if you see the parameter, what it says, it's width. So width it all about 1. So 1 stands for MTW, like this. If I say the width as 2, the string length will be like this. So if I say for 5, it would be like this. If I say for 8, like this. Not for like no. If every of them is having, if you could see 5, it's for MONDAY, it's 6, DUESDAY, it's 7, no. So in the cases where every letter is satisfied on a given parameter, then it is going to give those values. Okay. And what if this is a string, right? So you can just split it with a space value. Okay. And then you can just go on counting for the two values, getting for the two values, or in a count of 3 relatively to that. Okay, you can see it's coming, and after this you can have it in count of 2, I believe so. Yeah, okay, we have some more spaces in between, so it's fine. Okay, so this works. You can see the header actually coming in. Okay, and we can just map it with, okay, fine. So that's all for the calendar module. Anyways, I believe we will leave the date and time module for the next class. With the class, we'll be having objects and classes. We'll be discussing the date time module. Okay, we have that one left out. Or anyways, we'll be doing the date time in the web scraping class also. We can do that. Okay, so that's all for today. Let me just stop your video.